Hey guys, welcome to Math for Kids by a Kid. Today we are going to look at powers with whole number exponents, as well as exponent laws. A power is a number written in exponential form. It consists of a base and an exponent. So I'll show you an example. 8 to the power of 3. 8 is the base, and 3 is the exponent. I'll show you one more example here. 8p to the power of 3. 8 is the number that multiplies p3, and this is called the coefficient. And in this case, p is the base, and then 3 is the exponent. Now I will show you the 5 exponent laws. We're going to start with the first one. Let's say we have to multiply 8 to the power of 3 and 8 to the power of 2. And this is what it really looks like in repeated multiplication. As you can see, we are multiplying 8 5 times. So instead of saying, okay, solve 8 to the power of 3 multiplied by 8 to the power of 2, you can simply just say solve 8 to the power of 5, because it's equal. They're both equal to each other. This is called the product rule. And it states that when multiplying two powers with the same base, you can add the exponents. So if we look up here, 3 plus 2 equals 5, because right here we're multiplying 8 to the power of 3 times 8 to the power of 2. They have the same base, so we can add their exponents. So 3 plus 2 is 5, and so this is what we get. The next exponent law we're going to look at is called the quotient rule. So I'll show you an example of when we need to use when we need to apply the quotient rule. Let's say we have to divide 8 to the power of 3 by 8 to the power of 2. And this is what it looks like. So in this case, we're dividing, and because we are dividing here, we can cancel some numbers out. We can cancel both 8s on the bottom and both 8s on the top. And we're left with just 1 8. So this is also 8 to the power of 1. So 8 to the power of 3 divided by 8 to the power of 2 is really equal to 8 to the power of 1. In this case, we subtracted the exponents. So 3 minus 2 equals 1, and that's what we got the exponent 1 from. So the quotient rule states that when dividing two powers with the same base, you subtract the exponents to simplify the expression. We are now going to look at the next exponent law. the power of a product law. So I'm going to show you an expression here that looks a little different from the last one. So 7 times 9 to the power of 3. And this is what the expression looks like in repeated multiplication. By looking at this, we can simplify it even further. We are multiplying 7 3 times, so that's, and multiplying 9 3 times. So 7 times 7 times 7 times 9 times 9 times 9. And from here, we can use exponents. So 7 to the power of 3 times 9 to the power of 3. This is called the power of a product law. This is how we are applying it. And it states that a term raised to a power is equal to the product of its factors raised to the same power. So in this case, this exponent 3 is being distributed to both the 7 and the 9 here. I'm now going to show you the power of a quotient law. So I'll show you the example here. 8 divided by 9 to the power of 2, and in repeated multiplication it looks like this. And from here, we can see that 8 is being multiplied 2 times, so 8 to the power of 2 divided by 9 to the power of 2 for the denominator. So the same way as the power of a product law, the exponent is being distributed to both the numerator and the denominator. The last exponent law I'm going to show you is called the power of a power law. So here's the example. 7 to the power of 4 to the power of 2. And this is what it looks like. And from here, and it's being multiplied 8 times, so you get 7 to the power of 8, or 7 to the power of 4 times 2. So the power of a power law states that if you are to raise a power to a power, you need to multiply the exponents. So just at the top, we're multiplying 4 and 2, which is 8, and that's how we got this. So now we know all 5 exponent rules. Now I want to point out the 0 exponent. This states that any base with an exponent of 0 is equal to 1. So examples of this: 10 to the power of 0, negative 8 to the power of 0, with a bracket around the negative 8, 7 to the power of 0, 9 to the power of 3 to the power of 0, because we multiply them and we get 0. Now, when solving exponents with negative numbers, we need to be very careful as to how we look at the problem. So let's say we have to solve negative 7 to the power of 2. And this is what it looks like in repeated multiplication. And this is actually the same as this. So the bracket can be around 7 to the power of 2. So it looks like, and this equals negative 9, and this is our final answer. Now let's solve a slightly different expression. So still the same numbers, but the brackets placed differently. So it's around -7 instead of 7 to the power of 2. It looks like this in repeated multiplication. And this equals 49. And these two answers are not equal. But why? The bracket makes the difference. In the first example, the bracket was around the 7 to the power of 2, and the negative was left outside the bracket. So whatever answer you got from inside this bracket, this negative outside would automatically make the number in here negative, which is why it's -49. But in the second example, the negative is included in the 7, and then that's raised to the power of 2. So because it's included, you include that when you write it as repeated multiplication. So it's -7 times -7, and that's how we get 49. I'll show you another example here. So -2 to the power of 3 times that by put that to the power of 2. So to solve this, let's actually pretend that the 2 is not there. So let's just pretend we have this. So this is really just without the brackets. And so, as we learned from our previous example, this as repeated multiplication is. And then from here, we see that's -8. That equals this. And so this is what the bracket equals. And so if we were to plug it back into here, we'd get -8 to the power of 2. And because the negative is included in the 8, we include it when you write it as repeated multiplication. So it becomes -8 times -8, which equals 64. And this is our final answer. Now, I also want to point out one more thing. When you have a negative included in a bracket, and that's raised to the exponent, that can also determine whether the answer is negative or positive. So I'll show you, for example. You have -8 to the power of 2 and -8 to the power of 3. So for -8 to the power of 2, it looks like this. And then that equals 64. In the second example, it's which is 64 times 8. And this time it's negative. Now you're probably wondering, well, it's included in the number, so it should be positive because it's not outside the bracket. But just because the negative is included inside the base doesn't mean that it's always positive, because you also have to think about the exponent. In the first example, the exponent is an even number, so the answer is going to be positive. In the second example, the exponent is odd, so that means the answer is negative. So it depends on that as well. Thanks for watching, guys. I'll see you soon.